In this video, we're going to look at a probability problem which involves a multiple choice quiz. Suppose we have a quiz with 10 questions where each question has 3 possible answers. What we're going to do is look at the probabilities of randomly guessing. So this here is an example of what an answer sheet might look like. 10 questions. Each question has 3 possible answers. We can call them A, B, and C. We're going to randomly circle answers on this answer sheet without even reading the questions on the quiz. So, first thing we want to answer is, what is the probability that if I randomly circle one of these answers, I get that particular question correct? Well, there are only 3 possible answers. Only one of those answers is correct. So the probability that any one question is correct is 1 out of 3. So 1/3 chance that any one of these questions is correct. Okay, so if there's a 1 in 3 chance of getting any one question correct, what's the probability of getting any one question incorrect? Well, 1 out of the 3 answer choices is correct, so that means 2 out of the 3 answer choices are incorrect. Now let's consider the entire quiz. If we were to randomly guess on each of the 10 questions, what is the probability that all 10 questions are correct? So that means the first is correct, and the second question is correct, and the third is correct, and the fourth, and the fifth, all the way down to the 10th. Notice this is an AND problem, which requires use of the product rule. We see that the probability of any one question being correct is 1 in 3, so we'll be multiplying that 1/3 by itself 10 times for each of the 10 questions. So the probability that all 10 questions are correct is 1/3 raised to the 10th power. So caret 10, since each of these questions, the probability of correct is 1/3, and so that 1/3 will be multiplied by itself 10 times, which is equivalent to 1/3 to the 10th power. Notice it's a very small probability. What this output means is that we're working with scientific notation now. This 1.69351 minus 05 means to move this decimal place to the left 5 places. So another way of looking at this answer would be to have a bunch of leading zeros, 4 leading zeros in fact. Notice if I come up here on Excel, I'm in the home page, the home tab, and I come up here to the number and I change it to number, and then I increase the decimals. There we see we get the 0.0000169. So the other version was a scientific notation for a very small probability. Okay, how about getting the first 7 correct and the last 3 incorrect? Well, we know the probability of correct is 1 in 3. If we're looking at 7 correct questions, we would be multiplying that 1/3 by itself 7 times. And, which is multiplication, the last 3 problems are incorrect. Probability of incorrect is 2/3, and since there are 3 questions, that would be multiplied by itself 3 times. So we get 1/3 to the 7th times 2/3 cubed to get 0.00014. Now, if we want to find the probability of exactly 7 correct, we first need to know the number of ways to get 7 out of 10 questions correct, because we could have the first 7 questions correct, or the last 7 questions correct, or any combination of these 7 ways to get just 7 out of 10 questions correct. Notice I said a combination. This is a combination problem. From the 10 questions, we need to choose 7 of them to be correct. So we're doing a combin. So we go to Formulas, Math Trig, Combin, and from the 10 questions, we want to choose 7 of them to be correct. So there are 120 ways to get 7 out of 10 questions correct. Since getting any one of the questions correct is independent of getting any other question correct, then all the ways, each of the 120 ways of getting 7 questions correct has the same probability. So if I want to find the probability of exactly 7 correct, all I need to do is multiply the number of ways to get 7 correct with, or so times, the probability of any one of those particular ways to get 7 correct. So the probability of exactly 7 correct is 0.016257.